Here's the syllabus right here, just to say that where we're at. Today is Wednesday, September 30th. You have to finish your quiz for Chapter 5 by 8 p.m. I see a lot of you already have done it. I hope it was relatively easy. We will cover also Chapter 6, and be heads up that your Lab 3 is due on October 7th, right before your midterm. Your midterm will cover chapters 1 through 6. And that will be on that day, Monday, October 12th. Do not ask me how many questions are going to be on it right now. I started to come up with it. Last time I looked, there was 80 questions, and I'm trying to knock some of that down. It's going to be the same format, multiple choice, true, false. This semester, I will not put a programming assignment in it like I did previous semesters, but I'll just add a few more questions, because the more questions are, the less points there are. Of course, more chances are that you might miss one, but the point percentage would be less if there's more. So I'm still kind of making up for the midterm, but when you do it late at night, you get tired. So I will have it done before the midterm. And it's going to be online, and I think you probably have about 2 to 3 hours to take it. So you will have plenty of time. So let's go ahead and get started with Chapter 6. Notice once again, Lab 4 is going to be assigned, but you're going to need Chapter 7 to complete the lab, and that's why it's pushed off until after Chapter 7. Lab 4 should be one of the challenging ones, but if you understand all the concepts that we talked about, it should be relatively easy, because all the code and everything else will be given to you. You just have to learn how to plug it in. So let's go ahead and get our Visual Studio. Let me see if I can blow this up a little bit bigger. Can everyone see that better now, Visual Studio?
Yeah.
In this chapter, the last of the confusing chapters, or what I don't consider them confusing, but where a lot of students did not understand, this is the last of the toughest chapters, 4, 5, and 6. The idea of a function is to take your code and break it down to module components. In this case, the way we've been doing code is we would strictly just list out all the statements that we need to do, or we might put in an if condition or a while condition we wanted to loop it. But we have no mechanism for we create a function and say, I want to execute this periodically. I don't know when I need to call it, but I might need to call it more often. I might need to call it at different times or on a regular basis. But what it is a block of code that you can use by itself, that you can call it when needed. So it's going to break apart your main a little bit, because not all your code you want in main. So let's go ahead and talk about how we create functions in C++. We have already seen one function that we already have written, and that's main. Main is a function, but we, as developers, will never call it. Because if you call it, the program can become erratic, because when the function calls itself, it's a recursion, and then that's more of a complex topic about how we do iterations. We talked iterations with the loops, the while loop, the do while, and so forth. But you can also have a function call itself, and it builds upon each other. So that's a programming concept that we will not discuss so much in this class, but it is a topic that's discussed in more advanced classes. So to define a function, right now there's two ways to do it in C++, but we'll talk about one way first. To define a function, you must give it let me do this, function. Here's a generic function, out. When you define a function, in this case, outside of main, you must give it the return type. In this case, unlike main, where I have return type of int, I have a return type of nothing, because I don't return 0. I don't return anything. I have to have a function name. The function name is the same way of naming your variables. So same rules apply, and then you have opening and closing parentheses, and then that is it. All this function will do is display it to the screen, function. Any questions on that? This is the way you would define an entire function at the bare bones level. It could be other statements in here, but this is how you define a generic function. We're going to create more advanced functions and more things about it as we go through. With that being said, when I need to call this function from main, I would just simply use its name. So when this function gets called from main, right here, it's going to jump up here, execute these lines, and then when it's finished, even though it doesn't have a return, it knows it's ended when it ends its curly brace, and then it's going to go back directly underneath the statements after this function. So it's going to jump up here, go back to where it's called from, and start executing on statement 2 and executing down. This function does not return anything unlike main. If I needed to return a double or any data type that we talked about, I can have it return, if I have a variable, int double x is equal to 4.0, I can return that variable to the calling function. And hopefully, not all the time you want it, you can assign that return value to another variable. So that's how we can say we're going to return this value back to the calling function so it could be used later on. So here's an example of a function that can do some statements and return a single value. That single value could be an int, long string, structures, classes, any data type that we will talk about. But it can only return a single value. What happens in this case if we want to pass this function some parameters? So for example, value 1 and value 2. Value 1 is equal to 1, int value 2 is equal to 2. For me to do that, I would pass in the actual values. These are called arguments right here. Arguments. Actual values. They can be literals, but most time they are variables that you would pass. But inside here, this function, I have to tell this function that I have two values coming in and the data type that they are. int, and int. Notice these values, value 1 and value 2, do not have to match these value names. These are what we call parameters or placeholders. Because I can create 2 more values. And I can call this function again with these 2 values. So these are, when you call the function, wherever it is, a function can call another function, but the values that you actually are passing it are the arguments, and then these are just placeholders that you would use inside this function. When they are passed like this, value 1, value 2, they are passed by value. So if I do v1 is now equal to 10, v2 is equal to 20. Don't worry about this one right now. When I do C out here,
what the heck? How do you do that?
it will still display a 1. So any changes that I have to do to these placeholders, pass it this way, will have no effect on the actual values. But if I pass it by reference, and the way you do that is put an ampersand right here. In this case, value 1 would now be assigned to 10, and C out for value 2 will still be 2. Because when you have this ampersand right here, that means you are using the actual reference, aka the address of the value. When you do not have this ampersand in the function definition, then it's passed by value. So this one right here copies the value of value 2 to v2. It copies the value. So that means any changes to it is only seen inside this function. It's not seen outside. However, if I have this ampersand right here, it says, do not copy the value, give me the actual physical address. Remember we talked about addresses of value 1, and give me that. So now when I do this line number 10, value 1 is no longer 1 anymore. It's now 10 because I actually changed it in the address. So that is how you return. You have a function that can return a value, and then in this case you can pass in values to the function and change it inside the function and pass those values back. This is useful if you want to have a function return multiple things back, because you can only return one thing here, but you can pass in variables by reference and modify them where they can see the changes outside. Now, this is the nice way of writing a function. You must define your function outside of main in this class before you actually use it. Just like with the variables, you must define it before you use it. It's before main, so I'm defining this. However, if I do not define this function before main and I have it after main, it does not know about it. So we would have to give it what we call a prototype. But we would have to give it a blueprint of what it looks like by describing what the return type is, the name of the function, and if it takes any parameters. So as you saw before, we have a double right here. I had a function and we turned in, oops, I forgot to do this, because the other one had a reference to it. You would have to define what your function looks like. You don't have to define the code, what the function actually does, but you must describe what the header of that function looks like. Any questions of what we talked about right now?
What would happen if you, for example, in initial main, you initiate the values as integers? What if you put double function, double ampersand?
It won't know about that function because right now it will only won't find it. Because right now, see, double. I could do double double, but the function right here will not take it because this function only takes an int. But in this case, I can change this to be double, and it'll work. It must match. Does it make sense now? I have to match.
Yes.
That is the high level of what this PowerPoint slide talks about. And when you do your lab 4, you will be required to do functions. The whole purpose of a function is to make these functions, even though this is generic, reusable. You don't want to write the code over and over again. Developers, software engineers are lazy. I am lazy. When I worked out at one of my companies, they said, oh, I have to write all this, convert this time zone over here to Central Pacific, wherever the customer is. Yes. And like, oh, and I was about to cry. I'm like, oh my word. We're talking about all types of time zones, Mountain, Pacific. And they're like, oh, you do know that the function is already given to you. And like, we already wrote it. I'm like, what? And they're like, yeah, we wrote it. You don't have to do these calculations. You don't have to configure all these time zones out. There's a function over here. Call it and pass in the parameters that you need. I was so happy. I was so happy. Because you write this and I can call that multiple times. How many times I needed it. And plus, later on, you learn about it for those that go on. You can then automate this stuff to test your functions. So that way, if something changes about it, the build would break. And so that way it's caught early. So there's a lot of purpose of writing small modular programs because you can create, what we like to do is, in one organization, is create utility classes. It's something that's going to be used over and over again. We would write it and then have that, whenever we need it, we would call it. We wouldn't have to put it in all these packages. We'll just import that package with all the util classes in it and call it. So when you write your code and you see such as things of, like we did for the seats, we'll do that, how it's called multiple times to say, hey, what seats, how many seats sold for this? And we did a see in and see out, see in and see out. We would write a function that says, hey, give me a seat, the tickets for this, passing the parameters to it so it can display on the screen, and then use it and call that function over and over again. And we'll see that when you go to the in lab on Monday, it will help reinforce why we write functions. So let's quickly go over it. I did it at a high level, so let's see what it looks like. Slideshow. Please speak up if you have any questions, because I do not see the messages until I shrink this down. Like we mentioned before, functions give modular programming. It breaks a program into smaller manageable parts. You do not want everything in main. You don't want these huge functions with all this code in it. Remember, functions can call other functions. We still see that with main. So you would want your main class small and it just be the driver of your program. Say, call this, next call this, call this, call this, call this. And you create modular functionalities to do the work so you can use it over again. A function is a collection of statements to perform a task. Task, singular, not task, task. Make them short to the point. Motivation for modular programming improves the maintainability of programs. Yes. Simplifies the process of writing code. It does because you're writing smaller tasks. Testability, reusability. That's emphasis why I'm going to be grading heavily on your Lab 4 of reusability. Not copy and pasting code and creating another function. Can you understand the concept of writing a single function and calling that multiple times, maybe passing different parameters, to reuse it, to create a function and just call and copy and paste the code into another function, and so you have function 1, function 2, doing the same thing, you lost the whole concept. So that is what I'm going to grade heavily on your Lab 4. So for example, you have all these statements in main, and then you just generate smaller functions to reuse. Defining and calling a function. Function call statement calls a function to execute. Just like I showed in main, I call it by using its name, and then if I need to, pass all the necessary arguments. A function definition is the statements that make up a function. The things that you must specify in a function is the return type. If it doesn't return anything, the return type is void. The name of the function, same naming rules as variables, a parameter list if you need to pass values to it, and the body of the statements. That makes up the function definition. We see they're using an example of main, but remember, nobody calls main. If I see you call main, I'll give you a 50 on your lab. Do not call main. It is a function. It's called by the operating system, whoever will call it, execute your program, but yourself, do not call main. It leads into a loop, and it could be erratic. These examples that I saw some students write, it worked fine because the programs are small. So when they're small, you don't see the erratic behaviors that it could happen. So never call main. It's like they don't talk about go-to statements anymore. Don't do it. The int is a return type. That is the value it must return to the calling function. The calling function could accept it like I did before in the practice where I had double Y assignment and store the return type, or you could ignore it. You don't have to, on the receiving side, handle that return value. You have the main, which is a function name, a parameter list, in this case it's empty, and the body of the function, which gives the statements, what it's going to do. If a function returns a value, the type of the value must be indicated. Int, double, string, struct, class. We don't talk about unions. I think unions are going away. But you must specify the return type. If it doesn't, it's void. just like an example below. To call a function using a function name is followed by opening and closing parentheses. Print heading, remember it did not have any parameters. So we just do the opening and closing of the parentheses. If you don't have that, it's going to give you an error because it doesn't know what print heading is.
Hello, can you hear me?
Yes?
I was going to ask a question about return values. Do you know about promises, and do they exist in C++?
Do they have what?
Promises,
What do you mean by promises?
like async functions.
Synchronous, they might, Java and so forth have synchronous blocks of code, yes, but they could be handled differently than what other languages handle them. Like same thing with static variables, they are handled differently in different languages.
Like I was talking about in C++, is there such thing as using async await, or or have the return value be like a promise value that has to be resolved?
Well, when you have the return value right there, you must return it right then. So are you talking about asynchronous? When I'm thinking of asynchronous, it's returning that it can happen later on.
Yeah, asynchronous functions, if those exist in C++.
Yes, they do.
Like for
When you're thinking about asynchronous, I'm thinking about communications back and forth between different devices.
No, because I was talking about because asynchronous functions are supposed to be like for like functions that take like a while to do, and so that's what promises comes in. Then you have to like wait for it to finish and then resolve it.
Yes, but we're not going into that complex things. But yes, asynchronous means when you're finished, pass me back the results. Right? Because that execution of the function might take a while to finish.
Mm-hmm.
That's sometimes when you get to multi-threading and so forth.
Yeah.
But we're not covering multi-threading in this class. When called program executes, the body of the program is called the function. After the function terminates, execution resumes in the calling functions at the point of the call. Remember, after the function call is completed, it goes back to where it's called from. Here's an example. See out hello main. You don't call this when you run your program. It starts executing here. It goes hello main. We call the function by its name. It goes up here. Hello from the function displaying the message. Once it ends, remember it doesn't have to have a return. It knows because it's not going to return anything, and it ends when it sees its closing bracket right here. And when it's done, it goes back to line after the function. So in this case, display message was called. It goes to line 23 and continues on. Here's just a quick flow on how it works. Main can call any number of functions. Yes, you are not limited to the number of functions you can write or call. Functions can call other functions. Yes, you will be doing that. Function A can call function B can call C, and so forth. And even function A can call itself. So yes, function call itself. Compilers must know the following about a function before it is called: the name, return type, the number of parameters, and the data type of each parameter. If you do not have your function definition before main, remember if you have it before main, you don't need a prototype. But if you have it after main, the curly braces, you must define a prototype. And that's what they're talking about right here. Ways to notify the compiler about a function before a call to this function. Place the function definition before calling the function's place function definition before calling the function's definition.
Are there
That's kind of
a lot of
confusing
times
thing.
where you would use it after main? I mean, yeah.
What?
I mean, are you seeing yourself using a lot of prototypes, or usually defining it before main?
No. In the quizzes and labs, you would see prototypes because that's the way the questions are set up. But most of the time, Well, in my previous job, yes, I did see prototypes. It depends on how you want to write it. You do not have to write prototypes. It's just optional. In Java and other languages, you do not write prototypes. So it kind of depends on the precedence of how the code was written before it. If you're the first one writing it, then you can set up your own standard. Saying, I don't want to use prototypes, I'm going to define everything in main. Before main, but it's your call. In this class, you can use either. I'm not going to be picky. But all I'm going to do is say, be consistent on what you do. Does that make sense?
Yes.
In the quizzes and tests, there will be prototypes, but the way you write your code, you do not have to do it. Because other languages do not require, like Java does not do prototyping, but in some C++ I have seen it both. The last example I have had prototypes. But it all depends, because that was legacy code, and that's the way the developers or architects decided they wanted to do it. They didn't need to, but they did. So once you look in the workforce and you go forward and you see them writing prototypes, you should continue to write prototypes just to keep consistency. A lot of times where I see it in code, companies are consistent about being inconsistent. So always be consistent in the way you handle things, in the way you write it. Use a function prototype declaration like the function header. This is the header, and then this is the prototype. As you can see in this example, the prototypes go before main to describe, hey, main C++ program. Here is my almost like variables that you know that exist before I use them. And your function definitions will be after main. So that is why you need prototypes in this case. But if I take this first and second and move it before main, I would not need these prototypes. Place prototypes near the top. Notice what they are. They are placed at the top before main, but after all the preprocessor directives. Why would you do it after the preprocessor directives?
Because you need the preprocessor directives to understand that function type.
You might need them for your prototypes because you might need them because you're using something that is not part of the C++ language, like this string. You would have to put them after. Very good. Programs must include either the prototype or full function definition before any calls to the function. Compiler errors will proceed if you do not, because, like always, you must define it before you use it. Either use the prototypes before or put the entire functions before you use it. When using prototyping, can place functions definitions in any order in your source file. Sending data to a function is simple. You just specify that you need to use parameters. Values passed to the function are arguments. These A and B, these will be actual arguments that you pass in. When a function that holds the values passed as arguments are parameters. Right here, display 5 right here, this is an actual argument. This is the actual value. But this prototype right here, int, is whatever in the function definition will be called the parameter. It's the placeholder. Because you can call this display num with a hard-coded value of 5, or I could define a variable and pass a variable to it. But this parameter right here doesn't care what the actual value is. It's just a placeholder for this num. So remember the terminology. A for actual for the value when you call it. P for parameter for placeholder. And here's this example. It takes 5 and puts it in num and then display num. This is stupid. A parameter can also be called a formal parameter or a formal argument. An argument can be called an actual parameter or an actual argument. Don't know why this slide is here. I should delete it. It's stupid. Just know that the actual thing that you pass in is an argument and the other one is a parameter. No one's being formal. No one's wearing a suit and tie. So I don't know why they have all these formal terminologies. Just know argument and parameter. The prototypes must include the data types of each parameter in your list. So in this case, this only can take one int in the prototype. Notice in the prototype, you do not specify the name or the parameter of the parameter name. You just tell it the data type. In the header, the one underneath it, you must give it a parameter name. And then when you call it, you just call it with the arguments. Important notes. Value of an argument is copied into when the function is called. Hence, this val right here, the value in val, is copied the way it is written right now. We will change that up in a minute. A parameter scope is the function which uses it, which means that parameter life expectancy is just that of the function. Functions can have multiple parameters, yes, and the parameters do not always have to be the same data type. You can pass an int, comma double, comma class, comma struct. You can pass different parameters to it, but be careful of the order in which you list them. There must be a data type listed in the prototype and an argument declaration in the function header for each parameter. So which means if you have a prototype and you have your function header, they must match up in the number of parameters you have. Arguments will be promoted and demoted as necessary to match parameters. This happens when you talk about function overloading. We'll see that shortly. When calling a function and passing multiple arguments, the number of arguments in the call must match the prototype and definition. The first argument will be used to initialize the first parameter and so forth. So in this case, val1, val2, and val3. Val1 would be match up to right here, val2 here, val3 here. So when you take right here and 15 and you read in these values, val1 will be copied into show val here. Val2 will be right here, and val3 will be copied right here. And they're just doing the summation. Here's another slide that just says, hey, the order in which you specify them in the argument list is what they're going to be in the parameter list. What we just saw was what we call pass by value. When an argument is copied, when an argument is passed to that function, the value is copied, which means changes to that parameter will have no effect on the argument. Let's repeat that again. As it's passed by value, changes to that parameter will have no effect on the argument itself. So they're just showing you a copy of it copies. And this is just an example, it says functions can be used to implement user choice programs. For example, if you have a menu choice program, like press 1 for this, press 2 for 3, and press 3 for the function, you don't want to write that in a code over and over again in any area where that menu might come up. You want to write a function that displays the menu, and maybe when the user prompts that information, returns that parameter back to say, hey, they press number 1 or press number 2. So in case the menu options change, you just change it in one spot. You don't have to go back and find out all the places you copied and pasted code. Remember, modular programming, reuse. Reuse that function, but not copy and paste the code and create another function. The return statement is used to end execution of a function. Just like if it doesn't have a return statement, it returns when it sees the closing quote. Can be placed anywhere in the functions. Statements that follow the return statements will not be executed. Just like when I showed you an example with a break and continue. The code directly after the return statements was dead code because there's no way it can be executed, because once you hit the return, it goes back to where the function gets called from. Can be used to prevent abnormal termination of a program. In a void function without a return statement, the function ends at the last curly brace. Here, into numbers 1 and 2, divide. If argument 2, the bottom of the denominator, is 0, then you can't do the division because you can't divide a number by 0. So what they did is they put a return right here. Kind of poor programming style, but it is acceptable because now you have one way in to this function and potentially 2 ways out, line 32 or 34. Usually when you write functions, you usually want one way in and one way out. That is usually good programming standards, but sometimes with the performance-wise, you go by the wayside on that. But always try when you write your functions to always have one way in, one way out. A function can return a value back to the statement that called it. We might not have used a PAL, but like in the example I showed you before the lecture, I was able to return the value back. So right now, when 2 is raised to the 10th power, it's going to do the calculation and assign that to x. So this is what you call returning a value from a function. In value return functions, the return statements can be used to return a value from a function to the point of the call. Just like right here. Summation, num1 plus num2, return the results. And so the result type does not necessarily need to match those of the parameters. It depends on the calculation you want to do and what you want to pass back. Even though these are ints, this could have easily been passed back as a double, a float, or any other data type depending on the calculations. Just remember, the return type does not have to match the parameter type. You can return based upon an evaluation of an expression. It doesn't have to actually be a variable. Like in this case, they just says return num1 and num2. Here's an example. They do the summation of value 1, value 2, they assign it to total, and then they display it. So they're taking back the return value from sum and putting it to total. And here's just another example that they're doing. Double square, take a return value, number, and number. So you can use functions in a mathematical expression. So they're using area pi times the return value of this function. So you can nest functions within mathematical expressions. You can use a function inside an if statement. You can use a function inside a looping thing. Yes, you can use them in any place where they could be called. The prototypes and the definition must indicate the data type of return value. If they don't return anything, you must specify them as void. Calling functions should use return values to assign it to a variable, send it to a cout statement, and use an expression. So when you use a function that must be used as cout statement, return some value. I haven't tried to experience what happens if you don't. Does it give you an error or whatever, or garbage value? But if you're going to display something from a return from a function in the cout statement, or in a while statement, or an if statement, make sure it has a return value. Most of the time, like on the if statement or while statement, it would usually give you a compilation error. You can also, instead of returning numerics, you can also return a boolean. Hint, hint, hint. You can use a boolean because then you can use it in your if statements and while statements, or do while, whatever you need. Declare a return type in a function prototype and use it as a boolean. Function must contain a return statement that returns true or false. Right here, if this is even, it returns back a true. It's going to execute this. Else, if not, notice when they wrote it, it's going to return a data type of a boolean. And so when they did the calculations, true is assigned a status, or false is, and it returns the status. Local and global variables. I forgot to mention this when I did the lecture, but we could do it after the lecture. Variables defined inside a function are local to that function. All your variables in this class should be local. Do not put global variables. Global variables are frowned upon. The reason why they're frowned upon is if they're outside of main, anyone can see them, anyone can access them. It may make it like, oh, well, that makes it easy. But if that variable is used in multiple spots and it gets changed, it can be problematic. So most of the time when you see any global variable, it's usually as a constant because we don't want it to change. And normally you do not want a whole lot of global variables because everyone have access to it. So that would break one of the rules of least privilege. Give a function as much information it needs to do its job, but nothing more. Because if you have global, anyone that's running the program inside that has access to it. So do not write any global variables. If you do, you'll be marked down heavily. They are hidden from the statements in other functions which normally cannot access them. Because the variables defined in the functions are hidden, other functions may have separate, distinct variables with the same name. Remember, C++ allows you to have those names. Now, if you're in a function with that same name, you have to use a global variable. Uh-oh, you got a problem. So int main right here, these local variables, the life of it is just within that function. This number right here is local just to this. Local variables are not initialized by default. Remember when you were doing the debugging, we saw values when you declared them local, how they had like some garbage values in it. So be careful when you do that when your calculations. Sometimes you might see that when you try to assign something to that variable and the compiler might hiccup saying, this variable has not been initialized because you haven't. So local variables are not initialized by default. And this is just showing you the functions that they both can have the same name. A function's local variable exists only while that function is executing. This is known as a lifetime of that local variable. When that function is called, such that int, it says, hey, operating system, I have an int that I need to put in memory, aka we call it the stack, function stack. Puts that information on the stack, And then when the function leaves, it pops it off. That memory gets reclaimed. That variable is no longer in memory. When the function begins, its local variables and its parameters are created in memory. And when the function ends, the local variables and parameters are destroyed. This means that any value stored in a local variable is lost between the calls of the function. Global variables is a variable defined outside all functions in the program. Nobody write them. The scope of a global variable is the portion of the program from the variable definition to the end. This means that a global variable can be accessed by all functions that are defined after the global variable is defined. Once again, you write them and I see them in the program, you be counted off. Do not get in a habit of writing global variables. You should avoid using global variables because they make programs difficult to debug. Yes, give access to functions data that they don't need any part of. Yes, on security problems. Yes, do not do it. Any global variables that you create should be constant if you write them, but don't do it. Here's an example of global constants outside. It's outside all the main, so you can use them. You don't have to pass them to a function like you do local. You have direct access to them, but do not use them. Local variables are not automatically initialized. They must be initialized by the programmer. Yes. Global variables, not constants, are automatically initialized to 0 or null for characters. But no one's going to write global variables, so we should be safe. But just know that local variables are not initialized. Global variables are. Just as we mentioned before, a local variable's life expectancy is from the start of that function to the end, and memory is reclaimed. That's for local. However, with static local variables, that variable is persisted in memory. So it stayed associated with that function, but the variable value is stayed. So it stays in memory. Think of it like static clean on your clothes. It stays around. Local variables only exist while the function is executed. When the function terminates, the contents of the local variables are lost. Yes. However, static local variables retain the contents between each function call. Static local variables are defined initialized only the first time the function is executed. If we do not give them initial value, they would be 0. And here's an example when you do local call. Int local call display is 5, local call 99. But when you call it again, it displays 5 even though we're changing it. As you can see, local variables come back. However, if we do it as static, then now they're using a loop to call this function. They don't initialize that state num. Without this line is only executed the first time the function is called. We don't give it a value right now, so it's going to give a sign a 0. But once we call it again and again and again and again, we're incrementing it, so it sees that value changed. So if it's static local variables, they are only initialized once. If we don't give them a value, the value is going to be 0. And they persist the information, the value between function calls.
So the values also, is it retained? I mean, the variables also still contained in the scope of the function. They cannot be used outside.
Yes, don't use them outside because the scope is just within that function, but it persists their value. Does that make sense? The scope of it is just within that function, but between the function calls, it retains the value.
Okay.
And here it is again where they did 5, they just incremented 6, 7, 8. A default argument is an argument that is passed automatically to a parameter if the argument is missing on the function. For example, in this case, on the prototype, they have an int. If I don't specify it, an int is going to give that first parameter a 0. All right. Can be declared in a header if no prototype, and multiple functions may have them. And multiple parameter functions may have a default argument for some or all. If you know, this is what I call a concrete one, to say, hey, I'm going to definitely know I'm going to have an int, so it doesn't have a default value. You must define them first compared to these ones that says, hey, I'm going to give you a default value. And we'll see that in a minute. For right now, int 10, int 1. These both have default arguments. When I call this right here, it's going to know that it's going to have 10 and 1. So here's your loop that goes through it. You have a nested for loop. You have one row with 10 asterisks in it. So that is why they know it, 10 and 1. I'm going to pass it in 5. 5 is going to replace the default value of 10, and it's going to have 1. So you have one row of 5. In this case, I'm going to replace the default arguments with 7 and 3. So I would have 3 rows of 7. So I don't see this too much using default arguments this way. You are allowed to do them, but if you have ones that you know, like in this example, the concrete one and then potentially 2 default ones, you must put the concrete ones for certain first in your list and then your default ones at the end. You can't intermix. If not all parameters to a function have default values, the default ones are declared first. So I know I'm going to have an int here that I'm going to pass in, but these are going to might have the default ones. So I have to define that one first, then the default ones. You can't intermix. And you can't skip functions either by putting a comma separated in between. You can't have that. The way we talked about functions is passing it to arguments to functions, it was passed by value. So now if we want to change that argument seen outside, we must pass it by reference. So now we have 2 mechanisms to be used. One is a copy one, which is fine for protecting your data that I don't want any changes to. Performance hit, because it's copied, it depends on how big that is. Now we have a reference variable which says, do not copy my contents, but give me the address of that variable. So any changes I do to that parameter is seen outside. Faster, but error prone if you don't want to do the changes. A mechanism that allows a function to work with the original arguments from the function call, not a copy. So hint and hint. The other one we talked about was copy. This is the original. It knows the address. That ampersand gives the address of the variable. We'll see that ampersand again in chapter 9. And yeah, in chapter 9. Allows the functions to modify the values stored in the calling functions. Provide a way for the function to return more than one. Because remember, a function, when you have the return statement, can only return one. But what about if I want to return a value and pass back other changes? This is how you would do it. This is your beacon of Gondor, if you remember, like Lord of the Rings. If you see this, be cautious. A reference variable is an alias for a variable, defined with the ampersand. Changes to this reference variable, not a copy. If it doesn't have the ampersand, it's a copy. If this reference variable is seen outside. So when you see this, int main, now calling double. So right now, value is 4. I'm passing this in. I see this beacon right here. Notice the reference, the ampersand is in the prototype. It's also in the function definition right here. But when you use the actual variable, you do not need the reference right here. Just use the variable name. This takes the value, whatever it is, take it times 2 and assigns it back to this parameter. But this parameter is a reference variable. It has the ampersand. So the value right here, value 4 is no longer, value 4 is no, the value, let me see. It used to have a value of 4. Now that 4 no longer exists, it got replaced with an 8. So that's why when you display it right after the function right here, it is now an 8. And as you can see right here, 4, and it's now an 8. This is how you change the original values of the arguments you pass in. Each reference parameter must contain the ampersand. Spaces between the type and the ampersand is unimportant. Standard, it's right next to it. Must use the ampersand in both the prototype and header. Notice prototype and header, but not in the actual statements what you execute. You just use the name of the variable. Arguments passed to the reference variable must be a variable. It cannot be a literal because you can't change it. And cannot be an expression or a constant. That's kind of a misnomer. You can pass in a constant reference variable, but just make sure it is a constant, but it will be able to change the value. You're just doing this when you later on talk about that when it comes to different data types like structures and so forth. You would pass in a reference variable, but if you don't want any changes to it, you make it as a constant because you do not want to have that function change any contents, but it's used for performance-wise. When used when appropriate, don't use an argument should not be changed by a function, or if the function needs to return only one. In other words, what they're saying here is if it's an int, a primitive data type, and you don't worry about it need to be changed, pass it by a value if you don't care. Because if it's a copy, whatever someone after you changes that function and changes that parameter, it has no effect on the calling part because it's just seen within that function. However, if you're passing it as a variable and you make changes to it, you lose your original data because you're changing the original value. So it's seen outside. So they're just saying be cautious. Overloading functions have the same name but different parameter lists. I have seen this and wrote it. It's somewhat kind of good, but it can also be a headache. Can be used to create functions that perform the same task but take in different parameter types or different number of parameters. Compiler will determine which version to call. So for example, if you're going to say get dimensions, you can say void get dimensions and pass in one argument. Void get dimensions and pass in 2. Same name, same return type, same name, just different argument lists. These are what we call overloaded functions. Get dimensions, and they're just passing in different values. Same name, same return type, different parameters, we call them overloaded. Because why would you want to have get dimensions for int, get dimensions for double, get dimensions for this? So you would just write it once. Here's just an example, int square, int double. They're passing in different data types so the compiler knows which one to call. So you don't have to write a function called square int, square double. You just write it as square, one for int and one for double. And here's the code, exactly the same, just different data types. We talked about break and continue in the previous chapter. Here's another one called exit. Exit, unlike break, where it breaks the current loop that you're in, exit exits the entire program. No matter how well entrenched you are in your program, it exits. It can be used from any part of the in any function. Can be used to pass back an int value to the operating system to determine why it ended. That is why on main sometimes you see return 0. Usually return 0 means, hey, I'm returning back. I exit the program. Nice, no errors. Some programs you would see code that gets passed back, and you get then a dialog message saying error code like 13 permission. Oh, in Linux, I think error code that I usually see in Linux 13 was permission errors. These error codes that are passed back to the functions that you sometimes see in the dialog, developers have written to do that. So when you see the error code, they're going to say, what's the error code or what's the exact message? Because then they can look at the code to see where that is being used. So that is why you see these numeric codes sometimes being passed back. So it can tell the operating system to say, hey, 0, I ended successfully, nicely, error 13, I got some kind of permission errors, and so forth. They're used for troubleshooting purposes and to report back to the calling functions how you ended. To use this exit, you must use another header file, cscd.lib. When you exit, you can use numeric values. Error success, right here, I think this exit status will be 0, and this would be a 1. These are defined somewhere. I think if you hover over them, they'll give you the numeric values. Because they're all capital, they are constant. Stubs and drivers. I have written a lot of stubs. Drivers, I would want to say yes. I do that in testing cases. Useful for testing and debugging programs and function, logic, and design. For example, in your lab, when you do your grade, sometimes it's good to say, I want to call this function so many times, so I'm going to create a function, and now I'm just going to print out a cout statement saying, hey, I got here. So that would be a stub. It doesn't do anything, maybe display a message or do something simple to inform while you're building your program, it works. You're able to get to me. And here's my values. Good. That is a stub. Then later on, once you get your program to work, for the steps, you would take the code out of the stub and put the actual code you want in. But all a stub is just a placeholder to say, I got here, or display the values that I have to make sure you. So it's kind of good for starting your program up, just to make sure that you hit all the functions that you need to have. A driver, I consider this more like sometimes like a main. It calls something else. A function that tests another function by calling it. Main would be like, say, like a driver of your program. Call function 1, call this other function, and so forth. But I also have written driver functions for test utilities, which a testing suite which would call my function by itself, not in the program, just my function itself. And if it returns back a scenario, let's say if the user types in 1, it's going to display this to the screen and return this value back. I would create a function test, just calling my function outside the whole main program, just to test it. Because the purpose of that is if someone goes back and changes it, those test cases will be actually run when you run the overall build for your program. So you're catching your errors earlier on. So those will be drivers. That's what they say. It's useful for testing. That part is a little bit more outside the scope of this class, but that is what it's used for. Any questions regarding that chapter? Let me stop sharing. Stop sharing. Any other questions or concerns right now?
No.
Let me stop.